Good morning, dear students. In the last lecture, we have studied about the Coulomb's law as well as dimensions of epsilon naught. Today, we will study about dielectric constant. What is the topic? Dielectric constant. The dielectric constant is also known as specific inductive capacity. Specific inductive capacity. Right? Okay. According to the Coulomb's law, when 2 point charges are placed in free space, then what will be the force between that charges? According to the Coulomb's law, if 2 point charges are placed in free space, then there will be force of interaction between that charges, which is given by this expression, right? If instead of free space charges are placed in any kind of a medium, then what will be the force between that charges? The force between that charges, according to Coulomb's law, will be this, right? Epsilon naught is the absolute permittivity of the free space, while epsilon is the absolute permittivity of a medium. And in the last lecture, we also studied that the dielectric constant is the ratio of absolute permittivity in the medium to the absolute permittivity of the free space. By applying this definition, what we will get? We will get epsilon is equal to epsilon naught k. Put the value of epsilon naught k here, then what we will get? Fm is equal to 1 by 4 pi epsilon naught k q1 q2 over r square. This was the equation number 1. This is the equation number 2. Now divide one equation by 2. Dividing 1 by 2. What we will get? We will get F naught over Fm. F naught is equal to, and Fm is equal to, right? Here we divide F naught by Fm. What was the F naught? F naught was the force between the 2 point charges when they are placed in free space. Fm is the force between the point charges when they are placed in any kind of a medium, right? Here, according to the Coulomb's law, we put the value of F naught, and here we put the value of Fm, right? Now make the mathematical calculation. 1 by 4 pi epsilon naught will cut with this 1 by 4 pi epsilon naught q1 q2, ये भी कट हो जाएगा, आर स्केयर के साथ कट हो गया, तो ये जो k है ये ऊपर चला जाएगा, तो हमारे पास क्या आ जाएगा? एफ नॉट ओवर एफ एम इक्वल टू k. This is the definition of dielectric constant. Our topic was dielectric constant or specific inductive capacity, and by applying Coulomb's law, by applying Coulomb's law when charges are placed in vacuum and when charges are placed in a medium. We make the calculation and we find that the dielectric constant is the ratio of forces between point charges when they are placed in a vacuum to the force between the charges when they are placed in any medium. Clear? Then this is the mathematical definition of dielectric constant. This is the mathematical definition of dielectric constant. Okay, the theoretical definition will be dielectric constant. Dielectric constant. It is the ratio. It is the ratio of force between 2-point charges when they are placed in free space to the force between point charges when they are placed in any medium. Right? What is the mathematical definition of dielectric constant or specific inductive capacity, which is denoted by capital K? The definition is that it is the ratio of a force between 2-point charges when that point charges are placed in a free space to the ratio of force between the 2-point charges when their charges are placed in any medium. Right? तो ये हमारे पास क्या आ जाएगा, डाइलेक्ट्रिक को कांस्टेंट. डाइलेक्ट्रिक एक कांस्टेंट होता है क्योंकि ये फोर्स की रेशो होती है. देखो फोर्स की यूनिट क्या होगी, न्यूटन. नीचे वाले फोर्स की यूनिट भी क्या होगी, न्यूटन. न्यूटन के साथ क्या हो जाएगा, कट हो जाएगा. कहने का मतलब जो डाइलेक्ट्रिक कांस्टेंट होता है उसकी जो वैल्यू होती है वो कोई न्यूमेरिकल वैल्यू होती है. इसी कारण हम इसे क्या बोलते हैं, डाइलेक्ट्रिक कांस्टेंट. There are no units, no dimensions for dielectric constant because it is the ratio of same physical quantities. It is the ratio of forces. Or in the last lecture we have said that it is the ratio of relative permittivity. Again, it is the ratio of same physical quantities. There are two definitions of dielectric constant. One is it is the ratio of it is the ratio of absolute permittivity of the medium to the absolute permittivity of the free space. Again, it is the ratio of same physical quantities. So we can say that there are no units and no dimensions of dielectric constant. The another definition of dielectric constant is that it is the ratio of forces between 2-point charges when they are placed in vacuum to when they are placed in any medium. Okay. Also we know that for all the mediums the value of k is always greater than 1. The minimum value of k is 1 and that value is for air. For air the value of dielectric constant is 1 and for wax dielectric constant is 2 and for water dielectric constant is 80. Right? Okay, we can write minimum value of k is 1. For air k is equal to 1 and for wax k is equal to 2. For glass also k is equal to 2, because for glass the value of k is lies between 2 and 3, and in the calculation of numericals we usually prefer to use the value of glass is 2 or 3. Sometimes we use value of 2 and sometimes we value use 3. It depends upon the nature of glass. In the numericals value will be given. In the numericals value of k will be given, but for some materials you have to learn. You should know the value of k. For example, for air the value of k is equal to 1. You have to learn this value. And for a water the value of k is equal to 80, right? Okay, now what are the important facts of k? The first important facts of k is that there is one conceptual question which states that when salt such as NaCl, sodium chloride, is dissolved in water, when NaCl is dissolved in water, then in that case NaCl is split into ions. Why? Question is why? Because when both are charged particle, right? Because both are charged particle, Na positive and Cl negative. This is positively charged particle and this is a negatively. So there will be force of attraction in between these two ions. According to Coulomb's law, if both these charged particles will be placed in water, then the force of attraction in between the sodium and chloride will decrease, because the dielectric constant for water is 80. So the force between them is falls to 1 by 80 times. Force will decrease by 1 by 80 times when these same charges are placed in a vacuum. So that's why when NaCl is dissolved in water, due to the high dielectric constant of water, the force between these two particles, the force between sodium and chloride will decrease. That's why they will split up, right? उसके बाद है हमारे पास इम्पॉर्टेंट नोट के कोई भी ऐसा मीडियम नहीं है जिसके लिए जो के की वैल्यू हो वो 1 से कम हो, right? The another aspect is that when k becomes infinity, what will happen if k becomes infinity, right? From this expression it is clear that force is inversely proportional to k. What is the meaning of inversely proportional? If k increases then force will decrease, and if k increases to infinity then force decreases to 0, because in that case q1 q2 over infinity, what will be the value of this expression? 0. कहने का मतलब अगर k की वैल्यू इन्फिनिटी हो जाए तो फोर्स क्या होगा? 0 होगा, राइट? इन द केस ऑफ मेटल्स द वैल्यू ऑफ k is infinity, so in that cases the force, what will be the force? Force will 0. What is the meaning of this? What is the meaning of this force will be 0? The meaning of force 0 is that there is no force of interaction in between the charged particle, right? There is no effect if two charge are placed in any medium and the dielectric constant of that medium is infinity. In that medium there will be no interaction in between that charges. What is the meaning of this? There will be screening effect, right? Such process is known as electrostatic shielding. What is the meaning of shielding? Protection of one charge from another charge, because there is no interaction in between their charges. Why Why there is no interaction between that charges? Because that charges are placed in the medium, and the dielectric constant of this medium is infinity, and according to the Coulomb's law, if value of K is infinity, what will be the force between that charges? The force between that charges will be 0, right? Okay. Yeah, this is all about the dielectric constant. You have to note down on your notebooks definition of dielectric constant and the important notes about the dielectric constant, right? Okay, thank you.